and I'm recording them so you can go back and look at them later. So what I started with was just a review of the flip-flops. I didn't go through all the different gates and latches because mostly you'll be using flip-flops, but this is just to remind yourself of how these things work. I remember the last time that I dealt with 2742, at the beginning some people said they kind of wanted a refresher on it, so that's what I'm doing. So this first flip-flop here, what is that?
Is that a positive edge D flip-flop?
It's a positive edge D flip-flop, so positive edge. Okay, so positive edge triggered D flip-flop. And the characteristic table is like a truth table, and it's really easy for a D flip-flop. So I'll have my D input on the left and my Q output on the right, and I have QT plus 1, so that's what happens at the next clock cycle. And when D is 0, QT plus 1 is 0, and when D is 1, QT plus 1 is 1. So the D flip-flop just takes the signal that it gets, and that's what it outputs. The reason it's useful is that it does it on the clock signal. So it's not just like a wire that always has the same thing. And what we say about this is we say Q follows D. So Q is going to be whatever D is. Oh, and because it's positive edge, it happens on the positive edge of the clock. Okay, so what that means if this is your clock, and we're going to do an example of this in a minute. And that's your D signal, and this is your clock up here. Then your output is going to change on the positive edge of the clock. So I like to draw lines that are telling me where the positive edge of the clock is. And the positive edge is when it goes from low to high. And you have to know where Q started. So let's say Q started at 0. So it gets to a positive edge of the clock, and then it looks to see what D is. And D is 0, and so it's going to be 0, and it'll stay 0 all the way to the next positive edge of the clock. And then it looks to see what D is, and D is 1, so it'll become 1, and it'll stay that way all the way to the next positive edge. And then again it looks, and D is 0, so it'll come back to 0 and stay that way all the way to the next positive edge. And at the positive edge it's still 0, so it'll stay 0. So that's the positive edge triggered D flip-flop. So any questions on that? And for those of you who just came in, I did print out a couple extra worksheets if anybody needs one. And if you don't, that's fine too. Okay, so if this one is a positive edge triggered flip-flop, what's the one underneath it?
Negative.
Yeah, so that's a negative edge triggered flip-flop. And its characteristic table is exactly the same. So it does exactly the same thing that the positive edge trigger D flip-flop does. It just does it on the negative edge of the clock. So it waits until the clock falls from 1 to 0 or from high voltage to low voltage, and then it makes its change if there is a change to make. And so it's still true that Q follows D, it just does it at a different time. And I am sorry, my handwriting is so bad. I've got a tremor in my hand, and it makes my letters a little wobbly. Everybody good? Okay. All right, so next we'll look at the T flip-flop. The T flip-flop is a little bit different. The T stands for toggle, and toggle means going from on to off or off to on. That's what toggle means. And for our characteristic table, so T flip-flop. What happens here is if T is 0, then Q of T plus 1 is Q of T. That just means it's unchanged. So it doesn't change. So if the input is 0, then the output just stays the same. And if the input is 1, then the output is Q bar of T, which is a toggle, or it's the opposite of what it was before. So if we want to describe this in words, we can say if the input is 0, the output is unchanged. If the input is 1, then the output is the complement of the previous output. So if the previous output was 1, so previous is 1, then the next is 0, and if the previous was 0, then the next is 1, and that happens if the input is 1. So if the input is 1, the output depends on what the output was before. If the output before was 0, then the new output is 1. If the output before was 1, then the new output is 0. Can y'all see that okay? Yeah? Okay. Oh, and by the way, what is on these symbols for the flip-flops, what does this triangle indicate?
Positive.
Okay, yes, positive edge, yes. But what wire is going into it?
Clock.
The clock.
How does the clock affect the output?
On the T flip-flop, it's like the D positive edge trigger. This is positive edge triggered, And we're actually, we'll look at, I think I've got an example, I do. We'll look at an example of this. So what it means is it only changes at the positive edge of the clock. So at the positive edge of the clock, it looks at what the signal is, and then it either makes a change or stays the same. And then doesn't do anything again until the next positive edge. And if I'd put a little circle here, then that would mean it was negative edge triggered. And the last one, I don't remember if y'all use this or not in this class, but I figured we'd remind ourselves of it anyway. This is the JK flip-flop. And it's a lot like an SR latch, if you remember that from 2741. So it depends on both the J and K inputs. So if both J and K are 0, then it's Q of T, so unchanged. So J equals 0, K equals 0, no change. If J is 1 and K is 0, then the output is 1. It doesn't matter what it was before. So J equals 1 and K equals 0, Q equals 1. So that's a set. So, and if J is 0 and K is 1, that's a reset, and your output will be 0. So J equals 0, K equal 1, then Q will equal 0, and it doesn't matter what Q was before. And if J and K are both 1, then the output is the complement. So J equals 1, K equals 1, then Q equals, then Q toggles. So it toggles from what it was before. So if it was a 0 before, it becomes a 1. If it was a 1 before, it becomes a 0. Okay, any questions on that?